So whether we're graphing absolute value functions, which we just got done with, or we're doing radicals, there's going to be a whole heaping lot of similarities. For instance, in the last section, if we had a question like this, hopefully at this point you would look at that and say, ooh, I got this. I would have shifted right 2 and down 3. But in case you forgot for one reason or another, quick reminder, when we were looking at the absolute value functions, that number in the absolute value was my shift to the left or the right, depending on which sign it was. And my -3 was up or down, again, depending on what sign it was. So if I look, I'm like, okay, so -2 would be right 2. And the -3 on the end would be down 3. We plotted that point. We started taking our points to make our V, and we went. Same thing happens on radical graphs. So if I were to start at 0, 0, and I went down 3 and right 2, I would start in the correct place for my graph. Now, how we get the rest of the graph is going to be a little different, but note the shifts are the same. So when we do talk about transformations, we're still looking inside of this, just like we did here, and saying, oh, it's minus on the inside. It's still right. And it's plus on the outside. Oh, it's still up. Things changed. So now, let's see if anybody remembers. Somebody might. On number 2, let's just talk about all of them. There's 3 transformations on this one. What way are we going 3 and 4? Okay, so we're going left 3. We're going down 4. What's the negative outside do? Close. Close. If it was just a number, I'd agree, but what's the negative do to the graph? Okay, so the negative flips, but I'll put the math fancy lingo here. Reflects about the x-axis. In other words, it flips it, okay? It makes its mirror image. So that negative does mean something, okay? Number 3, let's play all 3 again. What about the 4 and the 3? We'll start a little bit easier here. Okay, left 4, plus on the inside. Again, same shifts as we have with the absolute value. Up 3. Now the 5, you're right. The 5 is like our A value. But instead of calling it slope with this, we're going to call it stretch. Now here's why. Because when these go, when the number gets bigger, it's going to stretch and get bigger, sort of like when you're first getting up, like, ooh, it's kind of tight here. That's what's going to be going on with this. So we'll see that as we play. I'll still show you on the calculator what you can do. But I think similarly to the absolute value, we're not going to need the calculator as much as you may think. So, here is the biggest key to graphing any radical function. What we like to call the parent graph. Okay? There's a certain set of points that are going to be helpful for us to use every time, especially if we just want to use the shifts. So, I will explain what the numbers are and why we use them here. So for square roots, we use 0, 1, 4, and 9. Well, why did I do that? Because for each of those, if I take their square root, I get a whole number out. Oops, hit the wrong button. Hang on a minute. We like whole numbers. Trying to graph decimals is not fun. It's not easy. So those are going to be our parent points. And so anytime you're graphing a regular old square root, that's the chart, that's the base you want to work from. So these are all just coordinate points. 0, 0, 1, 1, 4 on x, 2 on y, 9 on x, 3 on y. But here's the thing with square root functions. This end doesn't get an arrow. Let me show you why. We'll kind of use a little common sense here. Let me brighten that up a little. Okay, so notice it goes off to the right, but it like literally stops right there at the first point. If I pulled up the chart, 0, 0, 1, 1, 4, 2, I'm seeing all those. But watch this. I scroll up and I get all these error messages. Error, 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 error. Well, why is that? Because at this point, if you try to take the square root of a negative, you can't. It doesn't exist. It's not defined. And so that's going to be something that is going to be nice when we're pulling these charts because it's going to help us have a starting point. So we got a graph. Going off to the right with an arrow. Oh, Hardy, domain and range still? Yeah, but there's an awesome trick for this. Well, check this out. X values, left to right. There's my furthest point to the left. I'm at 0, right? So my x value starts at 0 and goes forever off to the right. Ranges. Starting with y. I know this gets repetitive because it's like, dude, we just got done doing this with absolute value. I know, but there's still things to make connections with. That point is also my lowest point at y equals 0. But here's the cool part, and it's going up slightly forever. Those are always going to match. So if you're looking at your chart, okay, the first pair of points you get is always going to be where your domain and range start. If you use the calculator, check it out, the first values after the error message, 0, 0, are where your domain and range are going to start. You always are going to have that clue. You're not going to have to think about it or calculate it. It's just going to be there for you. So that's kind of cool with the square roots. And we'll see some movements with them and things. But that's a good starting place for us to go. Now, slight difference, okay? Cubed root. Let me show you what one looks like first. And then you'll be like, Hardy, how do I put that in my calculator? To get the cubed root, you just press math and you go to number 4. There's my little cubed root. Whack, there it is. I'm just going to do it with x right now, because I want to see what this looks like first. All right, kind of looks like it's upset. Ooh. So we got the snake slithering across our screen. That's a little different. Let me pull my chart up. Now here's the first thing I notice. I don't see error messages anywhere. That's kind of weird. So let's just start jotting some of these whole numbers down, and we'll see where they come from. Hardy, for the love, how many are you going to do? As many as I can fit on here. Okay. So I get 5 for my cubed roots. Here's why I'm picking those 5. If I take the cubed root of each of those values, they're perfect cubes. Even the negatives are. So that's the one difference that we've got between square roots and cubed roots. I can do the cubed root of a positive or a negative and get an answer. So that's where these came from. They're my parent points. So if I plot those on here, whoops, I almost went a little too high. Oh, I did go. That is the right place to be. Arrows on both ends when we do cubed roots. And that's good news as well for us. Because when we go to do domain and range now, forever to the left, forever to the right. Always. It doesn't matter if it shifts, moves up, down, left, right, stretches, flips, doesn't matter. Infinite domain. So I turn my attention to range. I'm like, wait a minute. This is going slightly down and slightly up. Uh-oh. Free square, people. When you graph cubed roots, your domain and range are infinite every single time. That should be like the easiest questions ever when we see the next quiz. Because even if you just looked at the picture, you'd be able to see that it went forever in all those directions. But again, this is just my parent graph. Can I put it on the calculator? Sure. Am I going to show you how you don't need it? Yeah, I am. So, let's get down to business and start moving these around a little bit. Okay. All right, first things first. I know it says good points. I'm not going to pay attention to good points. I'm going to do my own thing. What two directions am I shifting? Okay. Left 5 and down 2. So I know one thing right off the bat. I'm going to go left 5 and down 2. That's where I'm going to start. So could I go to the calculator? I absolutely could. But here's what else I could do. Now, to some of you, you may think I'm nuts, and that's okay. It wouldn't be the first time. Check this out. Left 5 occurs on the x-axis. So I'm going to take the x values of my parent graph, and I'm going to subtract 5 from every single one of them. And down 2 happens on the y-axis. So I'm going to subtract 2 from all of my y values. But before I graph them, because I like to prove a point when I'm doing things, Hardy, I just want to do it on the calculator. Okay, second and x squared, there's your little square root logo. X plus 5. Be careful. The minus 2 is not underneath here. If you just hit minus 2, uh-oh, it's kept going underneath the radical. We don't want that. See how that little arrow is flickering to the right? Hit it to the right, and you're out. Got to make sure you're going to do that if you do this. And so I pull up my chart. Oh, check this out. There's the last error message. What's the first point? -5, -2, just like I said it would be. -4, -1. -1, 0. And wrapping up, big finish, 4, 1. You can use either. I don't care. I'm not going to make you do the chart thing. If you want to do the calculator, you absolutely can. But this is the one I want to graph. So -5, -2, -4, -1. -1, 0, and 4, 1. Again, square roots only arrow to the right. Do not arrow both directions on these. And just like we did, oh, transformations, Hardy, good job. Domain and range. First numbers right after the error. If you're doing the calculator, first numbers in your chart. If you're doing the chart. X value starts the domain. Y value starts the range. Every time. it doesn't change. It doesn't move. Nothing happens. And so when we're doing these, as long as you get your directions right, left 2, up 1. I could actually do my domain and range now if I wanted to. I got my point. But again, we don't have to do that yet. So now, it's a cubed root. Be careful. If you're going to go Chartalicious, just like we did on the square root one, it's nothing different. Left is going to adjust my x. Left 2 means I'm going to minus 2 on each of my x values. Up 1 is y. So I'm going to add 1 on each of my y's. So if I've done my stuff right, you know I got to check. And I know I'm going to have to call myself out if I did something wrong. Oops, that is not what I wanted. Hang on a minute. Make sure when we type it in, the x plus 2 is under the radical. We're good. Arrow out, plus 1. Let's pop the chart and see if we're rolling. -10, -1. Now there's no error messages here, so you're going to have to just trust the process. -3, 0. -2, 1. -1, 2. And wrapping up, bam, with 6, 3. Let's go. So we've got -10, -1, -3, 0. There's my -2, 1. Okay, so that's still one of my points. -1, 2, 6, 3. And again, cubed roots, we got snakes. And we also have the easiest domain and range ever. Every time with the cube. You don't even have to look at the problem. Number 4, you could go write the domain and range in right now without even looking at the graph. It's like free points. But again, I've taken it off of both each time. So it's totally your call on what that's going to look like. The only reason I'm going to do these last 2 is now you have numbers on the outside, and I want you to see how that changes things. So let's get to it. And do you have to write this chart down every time? Maybe not. If you know the numbers already at some point, that's cool. So here, left 1, -1 for the x. Up 3, +3 for the y. Calculator's a nice check if for nothing else. Ooh, I didn't do one thing though. I just noticed that. You're like, Hardy, yeah, what's going on here? So that negative, okay, that flip or that reflect upon the x-axis also means we have to multiply things by -1. Here comes the post-it note. Hardy did a boo-boo. So stretches also have to do with your y, okay? So when I'm doing this, I need to multiply y by -1, which is still 0, +3, I'm good. But here it's going to change an answer. 1 times -1 is -1, +3 is 2. 2 times -1 is -2, +3 is 1. And 3 times -1 is -3, +3 is 0. I'd have found that out as soon as I went to type it in my calculator. So let me put it in where we can look at it. Again, make sure your negative's there, your +3 is on the outside. Let me pull my chart. Okay, there's my error messages. -1, 3, 0, 2, 3, 1, and 8, 0 should be hanging out down here at the bottom. Plot those. Opening down. If you ever have a negative, it means it's going to open down. So what's that do as far as domain and range goes? A little bit. Are these still going to be the starting points? They're still both going to be apart. Domain left to right is still -1 to infinity. Okay, I got that. But for your range, bottom to top, the bottom is going down forever. So I have to start with -infinity, but I'm still going to use 3. It's just on the other end. That's the one time you've got to pause on domain and range, is when we get flipped like that, because that can mess some things up a little bit. Last one. So I want to make sure I'm very complete today, so when I put just one little thing in with this Wednesday, it's not going to be much to throw you off. What direction am I going to be going for in number 4? Right or down? Down, because it's outside the radical. So down 4, and we're going to stretch 2. Again, down 4 affects x. No, it doesn't. It affects y. What are you talking about, Hardy? And so does the stretch. So you're like, well, wait a minute. If neither of those affects x, and they don't, what do I do when I draw the chart? You keep all the x values the same. But for the y's, any stretches get done first, and then any shifts get done second. So you multiply the y value times 2 first, so 0 times 2 is 0, minus 4 is -4. Did I just... Oh my... Didn't see any of this. Nope, this is not here. Didn't see it. See, it's not... Oh, I didn't quite make that small enough. Let's fix this. Man, twice in one day. I mean, that's just uncalled for in so many ways. I just don't know. Yeah, I have to pay attention. Hardy, it's a cube. If it's a cube, you can't just ignore that fact and make it a square root. That is not going to be helpful. Thank you for the heads up, so I didn't completely make this with a screw up. So let's try this again. But correctly. The x's will still stay the same, even though I didn't have the right x's the first time in. So let's try again. -2 times 2 is -4, minus 4 is -8. Again, I can go straight to the calculator, and we will in a minute. -1 times 2 is -2, minus 4 is -6. 0 times 2 is 0, minus 4 is -4. 1 times 2 is 2, minus 4 is -2. And 2 times 2 is 4, minus 4 is 0. Oh, dear. All right. Let's get... Oh, wait. Before I do my cube, I got to get my 2 in first. So there's my 2. Now I'm ready to get my cube. And the -4 is outside. Okay. Did our patience pay off? Let's find out. -8, -8. Hallelujah. -1, -6. 0, -4. 1, -2. And there it is. Took me a minute, but we got there. -8, -8. 1, -6, 0, -4, 1, -2. That is one stretched out snake going through there. But still, does that change my domain or range? No. No, it's still a cube. Still a cube. So that's going to be where we wrap up the examples. Keep these out. Don't just put them away. Because momentarily here, when you get to play a little bit, and again, you don't have to go crazy with the play today. You'll have some time the next time we are together as well. But in the packet, you're looking at page 25 and 26. Sketch the graph, tell the shifts, do the domain and range. Totally up to you. If you want to make little tables, you have room. If you want to go straight to the calculator, you have room. Next time when we go to the video, I'm going to do a couple more examples just with a couple of twists in there a little bit. And we'll have a second time through this before we jump into our next piece of the pie. So make sure